Let's imagine that you are tasked with the job of determining which way water is flowing below ground. And specifically, you want to know the vertical component of flow, if water is flowing up or down at a particular location. To do that, you would go out and you would drill and you would put in these things called piezometer nests. So piezometer nests are groups of piezometers that are in the same place on the ground surface but they reach to different depths in the subsurface. And just to stress this point, if I put in 3 piezometers here, I want to stress that the scale here is on the order of 1 meter in the horizontal. So these guys are really close together, but that this distance is much larger relative to the horizontal distance. So maybe in this example, it's 100 meters. So there's a clear smushing of the scale here. So let's say that you went out 3 different places and you observed the following. In case A, you saw that the water levels in each piezometer were basically the same height. In case B, you noticed that moving from left to right in this example, the water levels systematically got higher. And in case C, you observed the opposite. The water levels decreased in elevation from left to right here. I now ask you, which of these has vertical flow and what is the direction of that flow? So in this case, remember that a piezometer is open only at the bottom. It's a solid casing. The well is cased with a solid piece of PVC, for example, all the way down here. And so it's telling you about the head at this particular location. And we'll annotate it on this one, for example. If this were our datum here, remember that we measure the elevation component of head relative to some arbitrary surface, the datum. Here, we would have this being the total head, H. But we could also break out 2 different components of head at this particular location. The first is going to be the elevation head. So at the point of measurement, at the bottom of this tube, this is the elevation component of head, Z. But then the height of the water column above the elevation point is telling you what the pressure head component is. Here is psi. And remember that H is equal to Z plus psi. So in this example here, we know that we'll call this one H1, and this distance here is H2. Remember Darcy's law, water flows from spots with relatively high head to low head. So right here in the subsurface, there's a very high amount of total head, most of which in this case is the pressure head. Right here, there's a relatively smaller amount of head in H1. And so if water's flowing from areas of high head to low head, it's going to be flowing up in this example. So flow is up, vertically upwards. In this example, if we were to draw our datum and look at the total head at each point where the piezometer is open, we would see that the total head relative to the datum is the same in each case. there's no vertical gradient in head here, and so there's no vertical flow. Finally, in our last example here, just to draw it out, we've got our datum down here. This is the elevation head, C1. This is the pressure head, Psi1. This is the total head, H1, at this measurement point where the piezometer is open. Here again, we have the total head, H2. We've got a little bit of elevation head here, and then a relatively larger amount of pressure head. So Z2, Psi2. Water is going to flow from places with high head to low head, and so it's going to be going from this measurement point where we measured this total amount of head downwards in this direction towards an area with lower total head. So here the flow is down. And I'll just emphasize this really important point that the point of head measurement in each case is the bottom of the piezometer. So because we've spaced these really densely horizontally, but they're open to different depths here, we're able to measure vertical head gradients. I'm going to emphasize for this particular example that we can't actually tell if there's any horizontal component to the flow. There may be. If we wanted to measure that, we would need to space our piezometers much more widely, and we would probably put them down to the same particular depth.